Okay, students, so welcome to Dr. Haider classes. So today we will discuss your very first chapter, that is real number. So before going to the real numbers, you have already read about the prime factorization. Prime factorization means suppose a number is 20 and we have to find its prime factors. So we will divide it. So 2 means by 2, then 10, then by 2 and 5. So prime factors of 20 is equals to 2 into 2 into 5. So we can write 2 raised to the power 2 into 5. Okay. So this is the process to find the prime factors. Means the number should be only in prime number. Prime number means, what is the meaning of prime number? A number cannot be divided by any other number except one and itself. So the smallest prime number is 2, right? So here is prime number. Prime number. So 2, 3, 5, 7, 11, 13. So all these numbers are prime numbers, right? And then one important point is composite number. So composite number means a number which is having or more factors. A number which is having at least 3 or more factors, you can say. A, a number a number having 3 or more factors, right, is called composite numbers. For example, we can say 4, because the factor of 4 is 1, 2 and 4, right? And then 6, then 8, then 9, then 10 and etc. These are the composite number, right? So after that we will discuss the fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Okay. So the fundamental theorem of arithmetic says fundamental theorems of arithmetic. Okay. So as per this theorem, every composite number means a number which is having 3 or more factors. So every composite number can be expressed or factorized as a product of primes. This is called fundamental theorem of arithmetic. Okay, and the theorem is already given in your book, so try to learn it. Anyhow, once again I am repeating, every composite number can be expressed or factorized as a prime. That is called fundamental theorem of arithmetic. Okay, now the next point is, in the previous classes we have already learned that HCF into LCM is equals to product of two numbers. Product of two numbers, right? HCF into LCM is equals to product of two number. If suppose LCM is given and product of two number is given, then we can find HCF is equals to product of two numbers divided by LCM, right? Or if suppose LCM, we have to find LCM and HCF is given, then product of two numbers divided by HCF, right? And if suppose HCF is given, LCM is given, one number is given, then how we will find the other number? So other number is equals to HCF, product of HCF and LCM divided by the first number or given number. So these are the very simple formula we will apply in this exercise. Okay. Now another few concepts regarding the concepts of HCF and LCM, right? So the HCF of two prime number is always 1. HCF of two prime numbers is always 1, right? Always 1. For example, a number is given 2 and 3, so of course HCF will be 1. And LCM of the LCM of two prime numbers will be equal to product of the numbers. Product of the numbers, right? If suppose one is given 7 and another number is given 9, so the LCM will be the products of 7 and 9, 63, right? And the third point is I want to say, if there are two numbers and one number is the factor of other number, means the first number is exactly divisible by the second number is exactly divisible by the first number, then SCF will be the, just say for example, we have to find the LCM of 5 and 10, right? So 10 is exactly divided by 5. 10 is exactly divided by 5. So the LCM of 5 and 10 will be 10 and SCF will be, SCF is equals to 5, right? So on the basis of this concept, now we will start exercise, okay? So exercise number 1.1 I am taking, okay? And the question says express as the product of its prime factors. The first part, that is 140. And this we have to express as a product of prime factors. So what we have to do? 140 divided by 2, take the prime numbers, 270, then 2, 35, then 5 into 5 means this 5 sevens are 35. So the prime factors of 140 are 2 into 2 into 5 into 7. So 2 to the power 2 into 5 into 7 we may write, and this is the prime factor of 140. So in this way we will find out the prime factors. Okay. So the rest of the question will do. Now the second question, the question number 2, the question number 2 says find the LCM and SCF of the following pair of integers and verify that the LCM and SCF is equals to product of two numbers. Suppose first part, numbers are 26 and 91. So by the prime factorization method, so prime factors of 26, we can write 2 into 13, and prime factors of 91, so that is 7 into 13, 13 sevens are 91. So first find the SCF. So SCF will be, what is the SCF? So this 13 is common in both the term, so the SCF is 13. And now what about the LCM? Whatever the SCF comes, write down, okay? If the SCF is coming 13, so this will be 13, and then the left out of the number, that is 2 and 7. So the product of this number is 7 2s are 14, and then 14 3s are 42, carry 4, and 14 1s are 4 and 18. So 182, this is the SCF, right? And now the question LCM. Now the question says verify it by the formula. So HCF verification, right? Write it here, verification. Verification. SCF into LCM is equals to product of two numbers. Product of two numbers, right? So SCF is 13 and LCM is 182 and the numbers are 26 into 91. Okay. Now check it. Okay, what will be the product on the left hand side? 13 to the 26 carry 2, 13 8 the 104 and 2, 106 carry 10, 13 1 the 13 and 10, 23 and this side do the multiplication. So 91 and 26, 6 1s are 6 and 6 9s are 54. Okay, and 2 1s are 2 and 2 9s are 18. So 6 6 8 5 13 and 1 1 2. So 2 3 2 3 6 6. So it is verified. Okay, so in this way we will verify. First of all, we will find first of all we will find the SCF, and then the second we will find the LCM. Okay, and after finding the SCF and LCM, we will verify it. Battery. So the next question I am taking, question number 3. Okay. So the rest of the question, you will solve the same type of question, second part and third part. You find the SCF and LCM and verify it by the product of two numbers. Okay. So now I am taking question number 3. So the third question, this is the questions related with the three numbers, right? So question number 3, first part. And the first part is find the LCM and SCF of the following integers by applying the prime factorization method. So this is 12, 15 and 21, right? So prime factors of 12, can we write 2 into 2 into 3, and the prime factor of 15, can we write 3 into 5, and the prime factor of 21, so can we write 3 into 7. So first of all, we will find the SCF, means the number which is common in all three numbers. So what is common? So this 3, 3, 3 is common in all three numbers. So SCF is equals to 3, right? And what about the LCM? So as I told you earlier, to find the LCM, whatever the SCF comes, write first. Okay. And now what is left? This 2 is left and this 5 is left and this 7 is left. So 2 into 2 into 5 into 7, and now find out the product. 3 2 is 6, 6 5 is 32 is 67 is 420. So the LCM is 420. Okay, got it? The second part of this question is 17, 23 and 29, right? And 29. So the prime factors, you see the 17 is itself a prime number, 23 is itself a prime number, 29 is itself a prime number. So as I told you in the previous, the SCF of two prime numbers, two or three prime numbers is always 1. So directly we can write SCF is equals to SCF of 17, 23 and 29, that is equals to 1. And what about the LCM? LCM of these numbers is equals to the product of this number. So 23 into 29 into 17, and whatever the product is coming, that will be the answer of your question, right? Got it? So next question, I am taking question number 4. The fourth question, question number 4, right? And the question says SCF, given that SCF of 306, so numbers are 306 and 657, and SCF is given how much? SCF is given 9. Then the question says find the LCM, right? So as we have already read, the LCM is equals to product of two numbers 306 into 657 and divided by SCF, that is 9. So you may cancel out 9 sevens are 63, 2 9 threes are 27 and 306 into 73 and find out the product, and whatever the product is comes, that is the answer. Okay, so you just do the multiplication and get the answer. Okay, now for the next question, question number 6. So the question number next question is question number 5. Check whether 6 to the power n can end with the digit 0 for any natural number n. So before going to this question, I would like to give some examples. Okay, suppose here the number is 20, here the number is 30, here the number is say 50, okay, and then 75 or then 35, okay. And now find out the prime factors of 20. So this is 2 into 2 into 5 means 2 square into 5. So 30 means 2 into 3 and into 5. And 50 means 5 into 5 into 2. So this is 5 square into 2. And 75 means 5 into 5 into 3. Okay, and 35 means 5 into 7, right? So these are the examples, and from these examples we are coming to the conclusion that a number is ending with the digit 0 are having 2 and 5 as a prime factor, right? Here 2 and 5 are having as a prime factor, so that's why this number is ending with the digit 0. Here 2 and 5 is the prime factor, right? 2 and 5 both are having prime factor, so the number ending with the digit 0. In the 50, the prime factors are 5 and 2 are there. Okay, so the number is ending with the digit 0. But see, in the 75, only 5 is given as a prime factor, right? 2 is not here, right? 2 is not here, so the number is not ending with the digit 0. Similarly, in the case of 35, so 5, the prime factor of 35 is 5 and 7. So there is no 2 as a prime factor. So that's why this number is not ending with the digit 0. It means that from these examples, we are coming to a conclusion a number must be ending with the digit 0 must have 2 as a prime factor, 2 and 5 both, right? 2 and 5 both. If 5 is there, 2 is not there as a prime factor, then never number will be never end with the digit 0. Okay, got it? So now see the solution, okay, how we will simplify this type of question. Okay, so how we will simplify this type of question? Just see. Question number, this is 5. And the fifth question is check whether 6 to the power n can end with the digit 0 or not. This is the question. So first of all, we will find the prime factor of 6, that is 2 into 3. So 6 to the power n means 2 into 3 whole to the power n. So now what we are observing, okay, 2 is there, but 5 is not as a prime factor of 6, right? So no numbers end with the digit. So either n is any natural number, right? So here we will write a 5 is not a prime factor of 6. So therefore, or you may write 6 does not contain 5 as its prime factor. Any language you can use. So simply you may write 5 is not a prime factor of 6. So hence no number ends with digit. Okay. This is the way to solve this question. Okay, whatever the number is given, either it is given, suppose 12 to the power n, and we have to check whether it is any number which is ending with the digit 0 or not, where n is any natural number. So the prime factor of 12. So this is 2 into 2 into 3. So 2 square into 3. So here again 5 is not having as a prime factor of 12. So it means no numbers end with the digit. Okay, got it? Okay, now the next question I am taking, question number 6. Question number 6. And the sixth question is question number 6. And 6 is explain. What we have to explain? Explain 7 into 11 into 13. 7 into 11 into 13 plus 13. And 7 into 6 into 5 into 4. 7 into 6 into 5 into 4 into 3 into 2 into 1 and plus 5 are composite number. It means we have to show that the solution, the number must have 3 or more factors. 3 or more factors, including 1 and itself. For example, you see the 4, and the factors of 4 are, 1, 2, and 4. So including 1 and itself, if a number is having 3 or more factors, then it is called composite number. Got it? Okay. So the smallest composite number is 4. A smallest composite number is 4. You must remember. Anyhow, so I am taking this part. So here the question is 7 into 11 into 13 plus 13. So 13 is coming common, right? Because 13 and 13, these are the common number. So we will write 7 into 11 into 1 plus 1. So this is 13, and 11 7 is 77 plus 1. So this is 13 into 78. So two factors already we are getting. One factor is 13, another factor is 78, third factor will be 1, fourth factor will be their product, or the factors of 78. We can write 2 into 3. So no need to find, no need to show all these terms. So you may write including 1 and number itself. Number itself are having more than 3 factors. More than 3 factors. So it means it is composite number, right? It is composite number. So in this way we will, right? In the same way, here what is coming common? This 5 and 5 is coming common. So take 5 as a common. So what is left? 7 into 6 into 4 into 3 into 2 into 1. If you want to write right, then plus 1, because 5 we have taken common. Then 5 into, do the multiplication. 2 3 is a 6, 6 is a 36, 36 4 is a 144, and 144 into 7, 144 into 7, 7 4 is a 28, carry 2, or 98 and 2 100. So 1008 plus 1, 1008 plus 1. Okay. So this is equals to 5 into 1 0 0 and 9. So two factors is already there. Third factor will be 1. The fourth factor will be the product of itself, right? So we can write including 1, including 1 and number itself are having more than three factors, so it is, thus it is composite number. Okay, so in this way we may solve this type of question. Got it? Okay, now the next question is the word problem. Question number 6. Question number 6. Sixth question I am going to take. Sixth question. Let me erase this one. Okay, now the sixth question. There is a circular, sorry, seventh question number 7. Okay, there is a circular path around a sports field and Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same, and suppose they both start at the same time at the same point and go in the same direction, after how many minutes will they meet again at a starting point, right? So here the numbers are Sonia Sonia is taking 18 minutes, okay, and then next name is Ravi. Ravi takes how many minutes? 12 minutes, okay. So the question says after how many minutes they will meet it again at the same point from where they have started. So we will find the LCM of 18 and 12, okay, by the prime factorization, of course. So the prime factor of 18, that is equals to 2 into 2 into 2 into 3 into 3, 3 3 is a 9, 2 is a 18, and then the prime factor of 12, that is equals to 2 into 2 into 3, okay, or by the long division method you can also find, but anyhow, so the SCF will be, what will be the SCF? This 2 and this 3, this is the SCF. SCF is 6, so SCF will be 6, okay. And what about the LCM? LCM is equals to whatever the SCF is coming and then 3 and 2. So the product is finally 36, means after 36 minutes they will meet again. Or you can find the LCM by the long division also, 12 and 18. So this is by 2, then 2 6 are 18 and 2 9 are 18, then 2 3 are 6, okay, okay, or 3 2 are 6, 3 2s are 6 and 3 3s are 9. So the LCM will be 2 into 3 into 2 into 3. Hence it is 36. So in this way, in this method also you can find the LCM, or otherwise find the LCM by the prime factorization method. So the LCM is coming 36. Okay. So after 36 minutes, after 36 minutes, they will meet, okay, at the same point from where they have started, okay. Now another tips I would like to give you, okay, in the word problem, if the question says if find the greatest number which when divided by this and leaving the remainder, so first subtract the remainder from the given number and then find the greatest number, means find the SCF, okay, and the least number means find the LCM, right? So be careful in this type of question in the word problem. So in this way, we have completed your first exercise. And if you are having any type of doubt or any sort of suggestion, please don't forget to write in the comment section. Thank you. Thank you very much. Now, the next is irrational number. Irrational number. Okay, irrational number. So before going to irrational number, let me recall what is rational number. Rational number means any number or any integer is in the form of p by q. Any integer is in the form of p by q, where p and q are integers. It may be positive or it may be negative, and q must not be equal to 0, right? Okay, where every rational number means every integer which is in the form of p by q, where P and Q are integers. P and Q are integers. Okay. And Q should not be equal to 0, right? So do you know why the Q should not be equal to 0? Because if Q will be 0, then it will not be defined. Suppose the number any integer divided by 0, so value will not be defined. Value cannot defined. Okay, not be defined. So that's why Q should not be equal to 0, right? And irrational number means a number which is neither repeating nor neither repeating nor terminating is called irrational number, right? For example, under root 2, under root 3, under root 5, under root 7, right? Or 2 root 2, or root 2 plus 3, or 3 root 3 minus 2, or 2 upon root 3. All are these irrational numbers, right? And in the irrational number, if we will do any algebraic process, then the result will be always irrational number. Here, irrational number is root 2. 2 is the rational number, and the product is 2 root 2, but the result will be irrational. Here, root 2 is irrational, 3 is rational, so root 2 plus 3, the sum will be irrational, right? Similarly, root 3 minus 2, irrational. Similarly, 2 by root 3, irrational. Any algebraic process, if you will do with the irrational number, then the final result will be irrational number. Okay, so now we are going to prove the question, and the very important question, right, for your board examination point of view or from your internal examination point of view. Okay, okay, prove that root 2, root 3, root 5, root 7, okay, these are irrational numbers. So I will explain one, root 2, and then root 3, root 5, root 7. You will try yourself. Okay, but I will explain. I am taking this root 2 because this question is given root 2 in your example, root 3 is in your example, and root 5 in your exercise 1.2, right? So better I am taking the exercise 1.2, the very first question, that is prove that under root 5 is an irrational number. Prove that under root 5 is an irrational number. Okay, we have to prove. Now, let root 5 is a rational number. But we have supposed root 5 is a rational number. So when it is rational number, so root 5 is equals to a upon b, where a and b are co-prime numbers, right? We will write a and b are co-prime numbers. So what is the meaning of co-prime numbers? Means the two co-prime numbers are SCF is 1, right? Means there is no common factor. For example, the number 2 and 3, there is no common factor except 1. Okay, so these are the co-prime number. 2 and 5, co-prime number. 5 and 6, co-prime number. Okay, so root 5 is equals to a upon b, where a and b are co-prime numbers. Okay, now squaring on both the sides. Squaring on both the sides. So squaring on both the sides, a by b whole square. So this is 5 is equals to a square upon b square. So it means that by the cross multiplication, a square is equals to 5 b square, and put it relation number 1, right? Suppose you are taking root 3. So in the case of root 3, it will be after the squaring, a square is equals to 3b square. If you are taking root 7, then after the squaring, it will be root a square is equals to 7b square. Okay, so the process remain same. So this is the a square is equals to 5b square. This is relation number 1. Now let a is equals to a is equals to, in the case of root 5, take 5c. Okay, so before that, a, a square is equals to a square is equals to 5b square. It means that, what does it mean? It means that a square is divisible by 4. This implies that a square is divisible by a square is divisible by 5, right? A square is divisible by 5. Now let or put a is equals to 5 in the case of root 5, 5c. In the case of root 7, put a is equals to 7c. In the case of root 3, put a is equals to 3c. In the case of root 2, put a is equals to 2c. So nothing of confusion. Okay, don't confuse. Now put a is equals to 5c. Where? From first. So from the first relation, a square means 25c square is equals to 5e square. So after the cancellation, 5c square is equals to e square. So this implies that e square is divisible by 5. Okay, b square is divisible by 5. So a square is also divisible by 5. B square is also divisible by 5. It means a and b also divisible by 5. A square is divisible by 5. So you may write a, therefore hence a is also divisible by 5. Here we write therefore b is also divisible by 5. Okay, so what does it? A is also divisible by 5. B is also divisible by 5. It means B are having 5 as a common factor. So this implies that if 5 is a common factor, of A and B, right? Which is contradictory. Why contradictory? Because we have supposed that under root 5 is a and b are co-prime number. Co-prime number means no common factor except 1, and here we are getting 5 as a common factor. So that's why there is contradiction in the result. So 5 is a common factor of a and b. So there is contradiction contradiction in the result. Okay, in the result. So hence our supposition is wrong. Our supposition is wrong. Okay, therefore under root 5 is an irrational number. Okay, got it? So This type of question, root 5, root 2, root 3, it always ask in the board examination or your internal examination to show that root 5, root 3, root 7 is an irrational number. Okay. Anyhow, for the uh, just to for perfection, I am getting the another number. Okay. I am getting another number, that is root 3. That is root 3. So in this way, you will get the revision as well as, and you are having no doubt also. Okay. I am taking root 3. They show that under root 3 is an irrational number. So let root 3 is a rational number. Okay. So when root 3 is a rational number, it means root 3 is equals to a upon b, a by b. Okay. a by b, where a and b are co-prime. Okay, co-prime number means no common factor. So now a squaring on both the sides. So root 3 a square is equals to a by b whole square. So it means 3 is equals to a square by b square. So by cross multiplication, a square is equals to 3b square. It means that a square is divisible by 3, right? Divisible by 3. So a square is divisible by 3. Okay. So therefore, a is also divisible by 3. Okay. And now put a is equals to what? 3c. Right? A is equals to 3c. So from first 3c square means 9c square is equals to 3b square. So this is cancel out. So 3c square is equals to b square. It means that this implies that b square is divisible by 3. So therefore e is also divisible by 3. So this thus 3 is a common factor of A and E, okay, which is contradictory, which is contradictory, right? Contradiction, or which is contradictory, you may write. Contradictory means we have supposed A and B are co-prime, but here we are getting 3 as a common factor, so which is contradictory or contradiction in result. So our supposition is wrong. Our supposition is wrong. Hence, root 3 is an irrational number, right? Okay, so in the same way, you can show root 2, root 7. Okay, now I am taking another type of question in the case of plus, in the case of minus, in the case of multiplication, in the case of division, right? Next question, question number 2. Okay, prove that 2 plus root 3, 5. 2 plus 3 plus root 5. 3 plus 2 root 5 root 5. 3 plus 2 root 5 is an irrational number. Okay. So in this type of question, no need to prove a root 5 is a rational and irrational number. Okay. So let 3 plus 2 root 5 is a rational number. Okay. So 3 plus 2 root 5 is equals to a by b. Now here we will write where a and b are integers. A and b are integers and is not equal to 0. We will write the complete definition of the rational number where a and b are integers and b is not equal to 0. Okay. Now do the like terms, rational part to rational part. Okay. So this is 2 root 5 is equals to a by b and minus 3. So therefore root 5 is equals to a minus b, a by b and minus 3 and whole divided by 2. This is the, okay. So as we know that root 5 is an irrational number and a by b minus 3 whole by 2 is a rational number because a by b is a rational number. So there is a contradiction because irrational number can never be equal to rational number, right? So here you may write since a by b is a rational number, a by b is a rational number, therefore a by b minus 3 divided by 2 is also a rational number. Okay, but under root 3 is an, or under root 5, whatever it is in the question, under root 5 is an irrational number. Irrational number. There is a contradiction in the result. On the left hand side we are getting irrational number, on the right hand side we are getting rational number, and irrational number never equal to rational number. So there is contradiction in result. So there is contradiction in the result, in the result. So our supposition is wrong. Our supposition is wrong. Hence 3 plus 2 root 5 is an irrational number. Okay. So in this way we can solve the case of plus, the case of minus, the case of multiplication. I am taking the one question of multiplication, that is question number 3, second part. Question number 3, second part. And the second part is 7 root 5. So 700 and root 5 show that 700 root 5 is an irrational number. So with the same process, let 7 root 5 is a rational number. Okay. So 7 by root 5 is equals to a upon b, and where a and b are integers, a and b are integers, and b is not equal to 0. Okay, and b is not equal to 0. So do the like terms. So by the cross multiplication, root 5a is equals to 7b. So root 5 is equals to 7b by a. Okay, 7b by a. So this is irrational number, and of course, if a by b is a rational number, then b by a is also reciprocal, will be also irrational. Rational number. Suppose 2 by 5 is a rational number, so 5 by 2 will be also rational number. So since a by b is a rational number, so this implies that 7b by a is also a rational number. Okay, but root 5 is an irrational number. Irrational number. So there is contradiction in result. There is contradiction in result. So our supposition is wrong. Our supposition is wrong. Hence 7 root 5 is an irrational number. Okay. In this way we will solve. Right. So, and the last extra question I would like to explain, if the question says, if the question says, show that root 2 plus root 3 is an irrational number. Okay. Show that root 2 plus root 3 is an irrational number. Okay. Irrational number. This we have to prove. This is the extra question I am taking. It may be root 2 plus root 3. It may be root p plus root q, whatever it is. And given that root 6 is an irrational number. This is given. Irrational number. Okay. Then show that root 2 plus root 3 is an irrational number. Okay. So in the same way, nothing to be confused. So let root 2 plus root 3 is a rational number. This we will suppose. So root 2 plus root 3 is equals to a by b, where a and b are integers and e is not equal to 0. Now squaring on both the sides. So root 2 plus root 3 whole square is equals to a by b whole square. Okay. And now apply the identity of a plus b whole square. So a square means 2 plus root 3 square 3 plus 2ab root 2 into root 3, and this is a square by b square. So this will be equals to twice of root 6 is equals to a square by b square and minus 5, 2 plus 3 5, and transfer to the right hand side. So root 6 is equals to root over 6 is equals to a square upon b square minus 5 and divided by 2. Okay. Now what is given? Under root 6 is an irrational number, but this is the whole result. A by b is rational number, so the whole result will be rational number, but irrational number cannot be equal to rational number, so there is contradiction in result. So our supposition is wrong, hence it is an irrational number. Okay. So now here after that you will write, okay, since root 6 is irrational number an irrational number and a by b is a rational number. Okay. So this implies that a square by b square minus 5 and whole divided by 2 is also a rational number. Okay. So after that you will write there is contradiction in the result. So our supposition is wrong. Hence it is an irrational number. Okay. Got it? So this is all about your first chapter, that is real numbers. Thank you very much. And if you are having any type of confusion, any type of doubt, please don't forget to write in the comment section and don't go anywhere. We will take the uh, next chapter, chapter number 2 in the next class.